In this recording, we are going to develop the idea of a derivative. A derivative measures the rate at which a function changes and gives the slope of its graph. So we're going to look at derivatives at a point and at tangents. You'll remember the formula that we had in previous recordings for the slope of tangent lines. Slope of a tangent line at P can be approximated using the secant line between P and Q and having H approach 0. The slope of a curve, y equals f of x at a point x sub 0, comma f of x sub 0, is the number m equals the limit as h approaches 0 of f of x sub 0 plus h minus f of x sub 0 divided by h, provided that the limit exists. The tangent line to the curve at P is the line through P with this as its slope. Now let's take the curve y equals 1 over x, and let's find the slope of the curve at x equals a, where a is not 0. A could not be 0, or our function would be undefined. So since we are looking at a equals 0, we're going to look at the limit as h approaches 0 of f of a plus h minus f of a divided by h. So we have just replaced our x sub 0 with a, since a is the x value we're looking at here. Well, f of a plus h is what we get when we plug a plus h into our function. So that would be the limit as h approaches 0 of 1 divided by a plus h minus f of a is what we get when we plug a in, so that's 1 over a, and this is all over h. Now since we have fractions within fractions, we have a complex fraction. To eliminate the two fractions that we have in the numerator here, we will choose the common denominator. The common denominator will be a plus h times a, and we'll multiply every term, top and bottom, by the common denominator. So this will give us the limit as h approaches 0 of, and we will multiply the first term in the numerator by a plus h times a, and we'll multiply the second term by a plus h times a, and on bottom, since we only have one term, we'll multiply that term by a plus h times a. Now this will eliminate all of our fractions. So this will give us the limit as h approaches 0 of a times 1, which is a, minus a plus h, and that's all over a plus h times ah. Now notice I left the parentheses on the top. I did this so that we would remember to change both signs. So this is minus a and minus h. Since we have a minus a, those will cancel, and we'll have the limit as h approaches 0 of negative h divided by a plus h times ah. Now since we have an h on top and bottom, we can cancel those. That will leave us with the limit as h approaches 0 of negative 1 in the numerator and a plus h times a in the denominator. Now we are at a fraction that is not undefined for h equals 0. So we can plug in our 0, and that will give us negative 1 divided by a plus 0 times a. a plus 0, of course, is a, so we have negative 1 over a times a, or negative 1 over a squared. So the slope of a curve, y equals 1 over x at x equals a, is negative 1 over a squared. So we can choose any a not equal to 0, and we can plug into this formula to find the slope of the curve at that x value. Now, where does the slope equal negative 1/4? Well, if the slope is negative 1 over a squared, and we want to know where that is equal to negative 1/4, then we have a proportion. We can cross multiply. Negative 1 times 4 is negative 4, and a squared times negative 1 is negative a squared. If we divide both sides by negative 1, we'll have 4 equals a squared. Remember, the opposite of square in a number is taking the square root, so we can take the square root of each side. Remember, when you take the square root of each side, we have to include both the positive and the negative. And the square root of 4 is 2, so we have to include both positive and negative 2, since 2 squared is 4 and negative 2 squared is 4. So where a is 2 and where a is negative 2, our graph will have a slope equal to negative 1/4. Here's a picture of a graph of y equals 1 over x, and you can see the 2 points where x is negative 2 and where x is positive 2, and at both points the tangent line has a slope of negative 1/4. If we think about this graph further and think about what happens as we get closer and closer to negative infinity, our tangent slopes are going to become, our tangent lines are going to become flatter and flatter, and so our tangent slopes are going to get closer and closer to 0. As we get close to 0, you'll see that our tangent lines start becoming much more steep. Same's true to the right of 0, we have steep tangent lines, and as we go around toward infinity, our tangent lines become flatter and flatter, and our slopes will approach 0.